Hi everyone, this is Shibish and welcome to Physics with No Big Words. In our first video, we talked about measurement and how measurement is how much of these things. Like measurement is an idea to express how much of things, how long things are, how short things are, how big, how small, and things like that, right? So how measurement explains how much. But physics is not only about how much. In physics, we study various physical attributes, and then not all physical attributes can be explained with only how much. So, if physics could be explained with only how much, then physics would have been mathematics. So, there would be no difference between physics and mathematics. But physics is different from mathematics because physics is more into the real side, real world. And in real world, what we have extra is in real world we have context. Get it? Context. So if I say he is here, then nobody will figure out who is here or who is where. There need to be context. There need to be the definition of he, and there needs to be the definition of here. So there needs to be a place, there needs to be an object, and things like that. Likewise, in physics, there needs to be a context. So what provides context to a physical body, physical object, or physical attributes we are talking about? So that's vector. Let me introduce you guys to vectors, okay? Scalars we talked about yesterday. Scalars is how much of these things. For example, this thing right here. This has a mass of 5 kilograms. Let's say this has a mass of 5 kilograms. No one can argue upon it, right? This has 5 kilograms. That means this has 5 kilograms. But if I say this moves 5 steps, then there is ambiguity. Then there is difficulty in understanding, because if this moves 5 steps, where does it move? Does it move backwards 5 steps, or does it move frontward 5 steps? That's where vectors come in. That's where context come in. Vectors are things that give context to the physical attribute we are talking about, okay? So some of the vectors I'll describe with this object. Vector number 1, displacement. So this is moving 5 steps. Let's not use steps because we yesterday talked about standard quantity, and standard in physics is in steps, in length is meters, okay? So this moves 5 meters, and then we give context with the vector. So displacement vector has 5 meters and then frontwards. So this moves 5 meters frontwards, and there is no confusion to anyone. Like if I say it moves 5 meters frontwards, no one could argue that where does it move? It moves frontwards, right? Okay, so that's vector number 1, displacement. Vector number 2 is velocity. So if I say this moves at a speed of 5 meters per second, so we assume that this is moving 5 meters a second. But where is it moving? So that is given by the velocity vector. 5 meters per second in right direction. So since I am defining it, so in my right, it is moving 5 meters per second. 5 meters per second, 5 meters per second. That's velocity. And what else are vectors? Velocity, displacement, force. Okay. I am exerting a force of 5 Newton to it. So I need to exert 5 Newton force. We have not talked about force yet, but this is just a preview. Putting force is, like pushing or pulling. But is it pushing or is it pulling? That needs to be defined with a context, because force is a vector as well. So I am giving a 5 Newton force to downwards. 5 Newton force downwards. I'm giving 5 Newton upwards. 5 meter upwards. Get it? Yeah. So all these are vectors, and then scalars are those attributes that could only be like only the numbers can suffice to describe these. Like its mass 5 kg and done. This is 5 kg, and then its length. Okay, let's say this is 1 meters, and there is no arguing about that. So that's scalar and that's vector. And in the next lesson, hopefully we can talk about motion and build an intuition of motion, how things move, and what happens if we put certain force in certain direction with context. Okay, yeah, have a great day.